Let's see. All right. Welcome everybody. This is the first installment of the AWS Usergroup, the Hague meetup that is virtual. We've been away for a couple of months, but I'm very happy to be back. And today we have two sessions for you, and you'll be watching this on YouTube. There is a little bit of a delay between when we talk and when you see things on YouTube. So when you are asking a question, please keep that in mind. There is no way for you to talk to us by voice. However, the comments are synced to us directly. We're on a StreamYard platform. So if you have any questions, please leave them in the comments section on YouTube, and I will see them. We will see them here, and we will we will discuss the questions that you have after the session is over. Today we have two speakers from us with us, both from AWS, Baruch and Paul. Welcome, guys.
Hey, Walter. Thank you for having us.
Yeah, well, very happy to have you. Maybe it will be good for you guys to introduce yourself real quickly, and then after that we'll go to start with Paul's session.
Okay, after you, Paul.
Hey, so my name is Paul van der Heijden. I'm a sales leader in specialist sales working on enterprise modernization. So I'm going to talk about that a little.
Nice.
Yeah, and
Baruch?
and I'm Baruch Furtunalar. I'm a senior solutions architect and part of specialist team in Microsoft architectures. And part of my job is to help customers move their Microsoft workloads to AWS.
Nice. Yeah, so thanks, guys. I'm very happy to have you here. I'm quite interested in the topic myself. As you know, I work for an AWS consultancy, so we do everything related to AWS. And one of the fields that I'm particularly interested in is the Microsoft workloads on AWS. Because I think that many people don't know the full capabilities and the full extent of what AWS has to offer in the Microsoft workloads space. So I'm quite curious to see what we can learn today. And as such, I guess we'll get started with Paul's session. So Baruch, I'm going to remove you from the stream for a little bit, and I'll come back to you after we finish with Paul's session.
Thank you. Good luck, Paul.
Thank you so much. So
so Paul, we'll get started with you, and just one more time for the people who just joined. We will, if you have any questions, you can leave them in the comments, and I'll be going through the questions with Paul after the session is done. Let me add your screen. Are you ready for your screen to be added, Paul?
Yeah, it should be available now. It says StreamYard is. Look at that. Awesome.
There you go. Do you want your camera to stay on during the talk, or do you want me to just show the screen?
What you prefer? For me, it's all. Maybe it's better for people to focus on the presentation than.
I like seeing people's faces because it adds a little bit of this is real, sure. And there's an actual person.
It is real. I am real. No, we saw it on Sunday at Lubach. Deep fakes, so no deep fakes over here. It's it's what you see is what you get, Walter. Okay, all right, awesome. Shall we start?
Yeah, go ahead.
Cool. So, hi everybody. Welcome to my presentation. I'm going to discuss a little bit about how we demystify, difficult word, modernization. So basically, what it is and how you and your organization can use modernization to solve your business challenges. My team focuses on how to modernize your application landscape and helps you with creating use cases, technical insights, and obviously the programs that support your modernization journey on on AWS. So moving on to the next slide, where we are going to discuss innovation velocity that drives business success. So what we see is that organizations rely on innovation to grow, deliver, and sustain their business. And that means basically that you're solving $10 million, $100 million problems. And these problems can be anything from responding to competitive pressures, taking advantage of disruptive technology, or capitalizing on a market opportunity. And once a solution is in place, then it's all about optimizing for agility, which you can see on the right side. And that means having the ability to move faster, that's saving money or maximizing human impact. Obviously, then it's about repeating that cycle, keeping on innovating and driving the business success. And the question is, how can business accelerate their innovation velocity? And over at AWS, we believe that businesses and organizations can accelerate their innovation velocity through IT modernization. And in this presentation, I will try to demystify what modernization means and help you understand exactly how modernizing with cloud native services, application development tools, and operating models can drive that business success. Looking at key challenges faced by IT organizations, we see that applications are the connective tissue that run and help drive businesses. And because of that digital transformation, IT decision makers are expecting their application portfolio to grow by 50% in the next 2 years, as businesses need new applications to support new customer experiences, new services, and new ways to use that data. And IT organizations, they face increased pressure to innovate and keep the pace of velocity to support their businesses. Excuse me. And they are saddled with the growing burden of maintaining that legacy infrastructure and applications. And Gartner's surveys have shown that although 88% of enterprise IT organizations have a cloud-first strategy, still 86% of their infrastructure spend is still directed to technology on premises. Apologies. And faced with these challenges of increasing costs, agility to scale, maintaining security and operational resiliency, and modernization can really help. Now, everybody talks a lot about modernization. What do we see is modernization? The way we define it is that modernization is the process of progressively transforming legacy application and infrastructure to take advantage of cloud economics and operating models. And the goal of modernization is to increase innovation velocity by maximizing resource utilization, adopting modern development techniques, and shifting from operational tasks where you can lower cost and you can focus on high value activities, increase agility, and reduce risk. What does it mean when you're translating the IT stack to cloud operating models? And let's begin by talking about the traditional IT stack and how it translates to different cloud models. Beginning with the infrastructure layer, it encompasses the hardware, the firmware management and operations of the server, storage, networking, and security resources in your current data centers. IaaS, or infrastructure as a service, is the cloud model that leverages a shared environment and on-demand model that provides the consumption of compute, storage, and network resources as a service while maintaining control and management of the configuration and environment for deploying your applications on it. Next, the environment layer refers to operating systems, runtime environments, management tools that you need to run your applications. The PaaS, or platform as a service, combines everything that comes with IaaS and provides end users as a platform to develop and manage applications without the complexity of you having to build or maintain the hardware and software infrastructure that runs it. Now, the architecture layer, that refers to how the backend architecture is set up. Function as a service, take PaaS to the next level by utilizing an event-based serverless architecture that auto provisions, auto scales, compute, storage and networking resources as needed. And developer or end user writes just functions and doesn't need to worry about provisioning, deploying, scaling, or managing the underlying infrastructure, environment, or architecture behind it. And finally, we've got the application layer. And instead of developing, deploying, and managing applications on our own infrastructure, SaaS or software as a service is a model where commercial software providers deliver the application and manage all aspects of the underlying infrastructure through a subscription model usually. And the last one is pretty well known. You've probably heard about Salesforce.com, Workday, and Office 365. Now, modernization equals transformation. Like we stated earlier, modernization is a process of progressive transformation of your legacy application and infrastructure. Now, depending on the application and use case or desired business outcome, we believe there are 5 key areas of transformation that we should focus on. Now, the first one is transforming your on-prem physical service to cloud instances. This will allow you to right-size your hardware and software, improve instance level elasticity, and the rapid realization of modernization outcomes. Second is the move from self-service environments to managed platforms. Now, instead of managing and maintaining your own SQL Server, Oracle, or even file server environment, a managed platform allows you to increase development velocity without dealing with the time and resource consuming activities of building and managing infrastructure, doing the software patches, or scheduling the backups. The third area of modernization, and now it becomes really interesting, it's transforming the monolithic application development model and infrastructure to a DevOps microservices-based model, utilizing serverless architectures and business-oriented, even event-driven functions. Now, within these three areas of transformation, there's also the opportunity to move from commercial off-the-shelf and licensing-based software models to open source-based software. Now, open source software helps lower the cost of ownership and improve on the agility of your organization. Now, finally, for the right workload or application, there is the opportunity to move from a custom or commercial application to a commercial SaaS model, and that's what we discussed. Now, with each of these areas of transformation, there's a proportional level of time and investment needed to realize the expected business value. So now let's dive a little deeper to see exactly how modernizing your infrastructure and application impacts cost, agility, and operation to increase that innovation velocity. Now, infra modernization means utilization drives costs down. That's a really important paradigm to understand. So let's start with infrastructure modernization and how utilization drives costs down. In an on-premise environment, servers, storage, and networking resources are often over-provisioned for a variety of reasons. Headroom for anticipated peaks and spikes in demand, long hardware cycles, bigger discounts for buying bigger than others. Now, the problem is that you're also paying for that excess power, space, and cooling capacity that you aren't even using. Now, these data center assessments have shown us that on-premises server utilization runs on average between 12 and 80% with a blend of dedicated application servers running around 6 to 10% utilization. Virtualized servers, we see roughly running closer to a 30% utilization. Now, as infrastructure is moved to the cloud, compute infrastructure is shared across a massive fleet of servers in highly optimized data center environments. And with the ability to scale resources on demand, server resources are right-sized to each customer's level of comfort, and that right-sizing that equally equates to about 1/4 of the server provisioned in the cloud that what companies had on premises. So that's a huge difference. And although it's significantly better than a dedicated server, a cloud instance like an EC2 instance is still carving out and reserving specific compute resources like vCPUs, memory, storage, and network bandwidth. So now if you move further to a managed platform like RDS, which stands for Relational Database Service, or EKS, our Kubernetes service, more resources are shared and automated, allowing even for more optimized utilization of compute resources. And finally, as you move to a serverless architecture such as Lambda, compute is consumed as a code, and that is triggered or executed in increments as small as 100 milliseconds. And this allows for billing to be based on true consumption of compute resources. So we don't have any reserved capacity, ultimately resulting in a lower cost per compute cycle. And hopefully this demystifies how and why infrastructures go down as you modernize. And we in AWS have seen examples where for the last move from EC2, for example, to serverless, we've seen a dramatic decrease of cost, sometimes going up to 1,400% less cost. So it's really impressive. Now let's talk about monolithic application development that stifles rapid innovations. So let's shift gears and look at that application modernization. Many legacy applications are burdened with long development cycles and the inability to quickly respond to new feature requests and infrequent product updates and releases. The challenge is that there are lots of developers and other functional roles that are still coordinating and aligning activities around that single complex application tied to a single delivery or release pipeline. Now, from a technical standpoint, functions within an application are often tightly coupled with many interdependencies, which lead to a significant amount of testing and validation for even the smallest of code changes. Now, this monolithic application development approach and processes is usually the fundamental bottleneck, and it really stifles that rapid innovation with legacy applications. Now, microservices, that really enables the DevOps model, and utilizing those microservices-based architecture enables the DevOps model that transforms that monolithic application development process into one that is built for speed and agility. Automation and self-service tools that are crucial to provide the ability to have small teams quickly and easily develop and deploy services that drive that rapid innovation, and a lot of that may sound already familiar to you. Now, application modernization, app modernization, that is where we decompose for speed and agility. So to address that challenge, the goal of application modernization is to decompose or reimagine monolithic applications, teams and processes into smaller, loosely coupled microservices and teams. And this approach provides agility to experiment and produce rapid innovation using less code, simplifies integration, and you get a much higher release velocity. Additionally, the operational responsibility, that's going to shift with modernization. So one of the key benefits of modernization is the ability to shift operational responsibilities, allowing you to free up resources to do more value-add and innovation-led activities. Now, there's a spectrum of shared responsibilities, options, across different levels of modernization, ranging from EC2, where you can build and run things, but you manage still your integrations, your scaling, your security configurations, etc., etc., in addition to your code, to a managed database, which is a little bit higher up in the value chain, or even managed container servers. And finally, we see the serverless functions like Lambda, where all you manage is your application. Now, that modernization delivers true economic value, and that is really important to understand. So where we've already talked about infrastructure modernization, application modernization and how the operational implications of modernization, efficiencies, increase in agility, improve that rate of modernization. So that's a really interesting graph. Now, on top of those benefits, increasing modernization adoption leads to increasing economic value. So if we look at our customers' data, they typically see at least a 20% savings in the unit cost of a CPU cycle with just a lift and shift migration to cloud infrastructure. Now, as the customers continue to optimize their cloud instances through right-sizing, license optimization, and selecting the best pricing model for their usage behavior, they typically see an additional 10 to 20% savings. So it's getting bigger already. Now, by adopting even higher level of modernization approaches and services, customers experience further cost savings, which many see savings of 60% or more. I'm going to talk about a couple of customers examples, but it's really interesting. Now, these savings, we always recommend them to be redirected or reinvested into driving more innovation and value-adding activities. Let's take some examples over here where we talk about modernizing your legacy Windows applications. Now, let's take a little bit of a deeper dive into what we can do with on-premise Windows applications. There are basically three main transformations that take place as we look to modernize legacy Windows applications and databases. First is moving the infrastructure from on-premise to the cloud. Often referred to as lift and shift or rehosting, it is simply migrating existing apps and databases to a cloud server instance. There's no need for code change. The customer managed the instance configuration, software managed, and for those customers who are running their applications on Windows Server VM, an environment can be easily set up and add to your virtualization estate. Yes. So, and once you're in the cloud environment, and that's an important thing. So, first in the first phase of relocate rehost, we already are able to achieve significant cost savings, as I already outlined in my previous slide. But now, if you're in the cloud environment, the next transformation is circling around re-platforming, and that's where the applications and databases go into a more automated and managed environment. And from an application perspective, that means moving from virtual machines to containers. Now, containerizing applications will help you develop, maintain, and deploy applications faster and improve portability. Now, AWS has several tools, and Barish will talk about them in a second, to help you automate that process of containerizing legacy applications. Now, on the database side, moving from a self-service model to a managed database server like RDS SQL Server, open source varieties like Aurora, will eliminate the need to do the activities such as provisioning, patching, and backups. Now, ultimately, then you're really freeing up resources for more value-add activities. Lastly, the third area of transformation is moving from commercial software licensing to open source. Now, many traditional commercial software vendors like Oracle, Microsoft, they have built their businesses around licensing. Software license agreements that are aimed at basically locking in customers and using punitive licensing terms to force upgrades and migrations. And oftentimes, commercial software licenses typically add 20 to 50% of cost on top of equivalent open source options. Now, in addition, those innovations are typically first available in open source or cloud native software before it's available in traditional commercial software vendors. So looking at refactoring your applications and database to take advantage of that open source community, of those open source options, can help lower cost, improve performance, and gain access to the latest innovation. Now, these three areas of transformation can be done progressively in stages or all at once, and that depends on the applications and the overall readiness of your organization. but there is no situation where it's not possible, for example, to mix and match these typical options of modernizations. And we've seen customers doing these simultaneously or sequentially. So that is all up to the organization and their appetite for modernization. Now, let's start with modern architectures. Instead of migrating an application, there may be a case to re-architect it using a microservices-based architecture, and then leveraging containers and serverless cloud-native services. That is, you can build modern applications that are modular, resilient, more secure, automated, and interoperable. And then you're fully realizing the benefits of modern applications. Some recent cost savings insights from more than 1,000 migration customers. Now, from these conversations we have with our customers all around the world, it is more important than ever that modernization and transformation be associated with cost optimization. So these two go hand in hand. It's about transforming and performing at the same time. So now, to create the right mental model for the rest of this conversation, I'd like to emphasize that we have studies from our cloud economics team who consult and talk to customer, that we see consistent cost reductions by moving applications to AWS. So in a CIO budget, 60% of cost is people. And shift to the cloud, it's not about lowering so much the cost of compute, network, and storage, but it's also lowering the cost of infrastructure per user of the data and the database costs. Now, if you look at, and I'm looking here at the slide on my left, so that's why you see me sometimes looking to my left, unlocking and lower that operating cost at scale, where you have a higher level of automation, it results in lowering operating costs all up, and that means less resources you need to spend on on operations, and more working on development and innovation, and that is ultimately having a shift of your cost from run your organization to change the organization. Now, let's move on to a customer case. And this is a Dutch ISV. It's an international software development company, but it's headquartered in the Netherlands, recently acquired by Open, a fintech in Amsterdam. And they're providing a solution that enables landing with the use of new technologies to maximize the value of their customers. Now, Davinci services a large number of larger financial institutions in the Netherlands, such as Rabobank and NN Group, Aegon, and the Volksbank, with the lending solutions. And by moving their Windows Server first to EC2 on the cloud, and then later on to Aurora PostgreSQL, they were able to significantly boost their financial application performance, and they deployed their customer applications rather in days than in months. And it was amazing to see. Our team was also part of that, and we were able to support them, enabling compliance by using AWS. And now, as I said, this company provides loan and mortgage software to financial institutions, and when they migrated their SQL Server, Microsoft SQL Server based application stack to Amazon Aurora PostgreSQL, they first did it, as I said, to EC2, and that led to immediate cost savings and agility improvements. And sometimes that's overlooked. Some people say, what's the value in that lift and shift scenario? But Davinci definitely saw a benefit in that. Not only that, while they were able to migrate everything to AWS, they also saw an opportunity to gain further performance and agility benefits. And after they migrated to Amazon Aurora, the open source database, it allowed them to scale to hundreds of thousands of credit dossiers in just a couple of months. And that was an amazing result to witness. Another customer, which I think is interesting, is Unilever. Now, they, probably many of you know them, they're headquartered in London and still in Rotterdam. and have subsidiaries in more than 90 countries, employing more than 170,000 people. Now, they had an aggressive growth strategy, and their company needed an infrastructure capable of supporting its specific digital marketing campaigns. And at that time, those web properties, they ran on an on-premise data center scattered worldwide, and they used different technologies and processes. Now, what they did was they standardized the global hosting environment, and that led to a new launch that led to the reduction of the lead time to launch a new website from 2 weeks to 2 days. And they also set up a standard billing model for those websites, and that allowed their partner, who was managing those campaigns, CSS, less than 12 hours to calculate that pricing for a campaign website. And previously, it would take them more than 2 weeks to get a quote back. Then they migrated 500 web properties in less than 5 months, and they were doing all of that using Amazon EC2, S3, EBS, VPC, and obviously our AWS support to fix that. Last but not least, an interesting case from Aon. That is a insurance company, actually a major international reinsurer company, and they're well on their journey to a hybrid model of on-cloud and on-premise applications. 3 years in, and they migrated hundreds of applications now to AWS, and they have a cloud-first strategy. The plus side is this has led to a 50% reduction in ideation to delivery time, and the cost optimization with the compute savings has led to an ROI of 30%. So again, amazing results. Also by first lifting and shifting and then modernizing their application infrastructure. Now, in short, OLA stands for Optimization and License Assessment, and that will provide data for those modernization opportunities in your organization. It's usually a great way to start exploring your modernization strategy. First, we determine how and what your current landscape looks like regarding performance, applications, versions, infrastructure, and that data will be instrumental to decide what migration strategy best fits your purpose. Refactor, replatform, or something else of the 7 Rs. And that can be plotted to the better modernization opportunity, whether that's a serverless architecture or an open source database. We can provide you with a purpose-built alternative. Now, next step is usually what we suggest is engage. And these are the activities we always do with our customers and prospects. We have facilities such as immersion days. We have the optimization and license assessment and the migration readiness assessment. All of three are vehicles or activities which we conduct in order to help customers prepare for that modernization journey. Now, in closing, I hope this presentation helped demystify organization, has shown you how modernization can help you increase innovation velocity for your company or your organization. So I will look forward to engage with you in a conversation to see how we can help you or hand you some new ideas. And that is actually the end of my presentation. I'd like to thank you very much and look forward to talking to you when that is of interest. Thank you.
Thanks, Paul. My apologies. I have 3 kids running in the background here, but that's the reality in work from home situation. So if you hear some screaming, then that's real life calling. Thank you very much for your session. I have a couple of questions. One is if people want to learn more about these engage steps, what's the best way, through their AWS account manager? Or?
That's an option. If you send an email to migrations@amazon.com, then somebody from the team will pick it up. I don't know how international the audience is, but we can then address these questions even internationally. But yeah, please feel free to send an email to migrations@amazon.com. Go to your account manager, or connect with me on LinkedIn. That's also relatively easy. Many ways.
Yeah. Okay. Cool. One of the things I always find quite interesting is somewhere near the beginning you're talking about the utilization of individual machines, and by having higher utilized machines, you can actually save quite a bit of cost. How do you go about trying to accomplish that? Do you have some insights on that? Because it's quite difficult, right? Because people are used to a fairly traditional way of doing things in a data center. So you plan for, I don't know, if you need to be able to scale 10x, you take 10x the capacity that you need, and you go from you take it from there, and then hope that everything holds together when you actually reach that 10x capacity. But how do you guys determine what the right level is for AWS?
That's an excellent question, Walter. So, and you're absolutely right. I mean, recently I was in a conversation with a car manufacturer, and they have certain peak moments when, for example, what was it, the Geneva Motor Show? Well, when it was still live, pre-corona, there was a lot of usage on our websites, the car configurators, etc., etc. Now, looking at that, what we do is we analyze with our tooling and our teams, in collaboration with partners as well, and of course the customer, the environment where their applications currently run on, and we get a very granular insight in what that means. So we can look at a per VM analysis, how much compute storage is needed, is used, average usage, peak usage, etc., etc. Now, and that really helps in mapping that to how that environment will look like on AWS. And on average, we see a saving of 36%. So that's based on our experiences. And the plus side is, so that's cost saving, you know. But what I also really like is that when you take away that hurdle for people in an organization, all of a sudden they see the opportunity to innovate as well. Because in the past, those legacy systems were a bit of a blocker to do something new. But now, if you can see, if you move from on-premise to AWS, saving that money, that means that, okay, this frees up my desk to do something new, whatever new it could be, like the application modernization I just showed. And that usually accelerates that innovation. So
it's my favorite part when people realize that. This stuff is a lot. It enables me to do a lot of other things that I've wanted to do for a while, but couldn't.
Absolutely. Walter, we try to remove that blocker, that financial blocker, and that will allow organizations to start looking at that innovation opportunity. But having said that, as I said in my presentation, both things are important, because otherwise, like one of our solution architects says, it's going to be a tech fest, and while we all love it, someday a controller will look at that and will not like it, and yeah, we got an answer for that. So anyways, great question.
Yeah, I mean, the cost optimization is, I think, one of the two biggest. Cost optimization and security are the biggest questions that I see in my day-to-day work, and it's not a super straightforward thing because
No, we use tooling, automation for that. So by scanning, discovering it. In addition, we also help customers create those use cases, those financial use cases, but not just finance. It's also where we say, okay, well, you got this particular application, it runs on that VM, and we think it looks the best on a Z1D instance type with this type of memory, etc., etc. So we're actually looking at that detailed level because you got to answer for it. It needs to make sense. You don't want to have it too conservative, but you also don't want to have it too optimistic. It needs to be real.
Yeah, exactly. Yeah, and I see that with most of our customers that usually takes a while for them to kind of get also the full buy-in on learning how this stuff works and learning the new ways. Because when I have discussions with people who are just new to this story, usually they have a lot of question marks on their face when they first get to the financial picture, because they're used to having a single bill that they pay for the next 5 years. There's an investment, and then they're done thinking about costs, and now they have to kind of continuously monitor this stuff.
Absolutely, yeah. And that is why it's so interesting, if you have a greenfield situation where somebody comes to you and say, hey, I got this great idea, how can I build this? Relatively, it's easier, because you got a blank sheet of paper and nothing can stop you from there. But if you look at, that's what we in our team see in enterprise modernization, there is something there. In large organizations, it's big, it's complicated, it's difficult. And the flip side is leaving it as is also not an alternative, because what we've seen at Amazon, for example, where we moved from an Oracle data warehouse to our own solutions on data warehousing and analytics, that was not an easy task. But everybody at Amazon knew that is something we had to do in order to get to the next level. And then you start cracking, you just start building the business case, the use case, technical side. Now that was quite a difficult project. But it shows that at the end of the day, after the hard work, you arrive at a better place. And that's what we love to help our customers with.
Yeah. I usually advocate a mix of obviously when it's bigger things, proper planning and making sure that you know what you're going to get yourself into. And when it's about smaller things, I'm a very big advocate of asking for forgiveness is easier than asking for permission. Especially in enterprise organizations, I see a lot of times where people have really good ideas and they're being stopped simply because of the planning side of things. And I always say, if it's not taking you too much time and it doesn't take too much money, I mean, obviously, if you're talking serious amounts of money, then it's a different story. But if you, and this is also something that AWS, in my opinion, does really nicely. If I think, okay, I want to try this managed database, then I can just do that, spin it up in a dev account, and take a small instance, play around with it, and an hour later I turn it off, and nobody will lose a night's sleep over it.
Absolutely.
Anyway, thank you very much. I'm very happy to have you with us. I will add Baruch back to the stream. Baruch, are you ready for action?
Yeah. Thank you, Paul. That was a great presentation, very insightful. Yeah.
All right. So Paul, I'll remove you from the stream. Thank you very much. You're welcome to watch Baruch's talk as well.
Thank you so much. Bye. Have a great presentation.
Thanks, Paul.
Thanks.
All right.
Baruch. First of all, this is officially a user group meetup, so I have a beer here, and
I'm okay.
I hope there are
I
other people,
just have some water.
other people on the stream. I would really like to be in person, so we can do this. One of the other things that I should mention, we had a quite interesting situation. Meetup.com broke right before the meetup started, and it's still broken. So they have some serious downtime on their hands, but it shouldn't matter for us. Yeah. We'll make sure to distribute the stream afterwards so people can watch it back.
Yeah, exactly.
If they have trouble. Okay, great. I'll add your slides to the stream, and then I'm happy for you to take it away.
Yeah, you can also remove me. I want the whole screen for this one.
Yep. All right, then I'll remove myself as well, and then you can't hear me anymore. So good luck.
Thank you. See you later. An infrastructure background, so not surprisingly, things that I covered today are related to Microsoft workloads. So related to customers.
Barish?
Hey.
Sorry, I think I did something wrong.
Oh.
I removed your video from the stream as you asked, and then that also removed your sound.
Oh, right. So I have to start over.
There was nothing. There was nothing. Yeah, it was my my bad for the layout. So let me try it again. Now, can you talk now?
Yeah, can you hear me?
Yeah, perfect.
Okay, great. So, yes. Okay. So again, my name is Barış Fırtınalar. I'm a Microsoft Specialist SA with AWS. I'm coming from an infrastructure background, and not surprisingly, things that I covered today, I related to Microsoft workloads. So related to the customers that I have, customers that I helped move to AWS, or customers currently making that move to AWS. They are kind of complementing what Paul mentioned also. So the name of the session is I Didn't Know AWS Can Do That. So basically what I will cover is while putting this session together, I reflected on my previous customer interactions. So I asked myself, what are the stuff that really caused customers to say, oh, we really didn't know AWS can do that. And in this 200 level session, I will try to uncover some less well-known services and features that our customers are putting to great use when they're running their Microsoft workloads to AWS. The pain points the customers have, the requirements, expectations. And when I sat down and started writing these topics, I realized that the list was getting longer and longer. So I decided to spread it across multiple sessions. So this will be the first part. And here's today's topics that I will cover. I'll talk about AWS App to Container. And then I'll also talk about AWS Launch Wizard for SQL Server, what it is, what it solves. AWS Dev Fabric for SQL Server again. And this is a nice solution that some colleagues from US developed, some solutions architects from US developed. And the last part would be around Amazon CloudWatch. And there are two nice features that I really like to cover. One of them is application insights for .NET and SQL Server, and the other one will be CloudWatch log insights. So let's start. So first one comes for our modernization savvy customers, container fanboys, AWS App to Container. It's a pretty new tool that we released. But first, let's talk about the modernization, right? Because the modernization could mean many things to many people, many different people. We're probably talking about applications that were created like maybe 10 to 12 years ago. Maybe the development cycle, the development process of applications has changed so much over the years. Things that were created 10 years ago, they are still usable. Like, the logic is being run in the business, the enterprises are running their business around it, but they are not meant for today's way of developing applications and releasing these applications. So this application could be a big monolithic application. It's not really agile enough. It may take like, I don't know, 3 to 4 months to make any changes to the code and to redeploy all that kind of stuff. In today's world, businesses cannot wait that long, right? They need to make a change today and deploy the change in like a couple of hours, maybe in 2 hours, right? And that's the level of agility the businesses have to react to the changing market conditions. There are competition, all kinds of stuff, right? So the agility is the most important thing in modernization. With all those older applications sitting out there, it's not possible, right? When enterprises think about modernization, there are multiple ways they can do it. It can be like they have these applications, they want to take advantage of modern infrastructure, like new CI/CD technologies, management and monitoring of these applications. They can just take it, push it into cloud, like lift and shift migration of their VMs. So it's called like rehosting the application. That's one of the ways, right? There are many ways you can do it. It could be like you are refactoring the code, like some of the code that you have, for instance, like a .NET, Microsoft stopped supporting the legacy .NET, right? And of course, that stopping support doesn't mean that they are not releasing security patches. They're of course doing it, but the innovation around the legacy .NET is no more, right? So all the innovation, all the new things are going to .NET Core. So it's kind of unsupported framework. So now there are like millions of applications that are sitting on .NET. So those applications need to continue to be supported by customers, and they need to find a newer platform. Maybe there is an opportunity to refactor some of this code and continue to evolve that code. So if you have like in-house development, right? It makes perfect sense that you can develop the code. You have the coding in-house. You can do some refactoring, and after refactoring, you can re-platform it to the cloud environment. So that's another option here. In some situations, the enterprise customers have bought some commercial off-the-shelf applications, which is very common. And some of those applications, you don't have anything, you don't have the code. It's just been sitting there for 10 plus years, but you still have a dependency on those applications in your business. So those applications, you probably just want to take advantage of the modern architectures. You want to just move them to the cloud, so maybe containerizing it and moving it to cloud. It's kind of also replatforming. So there are a lot of options customers have when it comes to modernization, right? So we recognize that there is an opportunity, and we launched 2 new set of tools. One is called a portability assistance for .NET applications, which really helps customers to take their .NET application and provide them with the ability to look at the compatibility of that code to move to .NET Core, right? .NET Compatibility Assistant helps customers to identify the compatibility between their current code and the destination, which would be .NET Core. In addition, for the coding system, like we announced, we also launched App to Container, which is the topic of today. And this is where we can help customers to take their applications, containerize it, and deploy it to AWS. We are going to dive a little bit deeper on this talk. I know many of you are familiar with containers, right? But I think it's also important to kind of sort of reestablish this baseline of why containerization is important. Docker got very famous on the idea of building once and deploying anywhere, and sort of the flagship mantra of containerization, right? But it's clearly more than just the ease of use of deploying software. So what are the biggest values that customers find when they containerize their applications? Like the benefits of containerizations, mainly the agility and portability. So you build once, you run anywhere. If you roll back maybe 20 years ago, like Java, the whole premise of Java was not to build an application from anywhere, right? In today's world, it's containers, right? Everything fully packaged, and nobody can complain about a missed dependency or you missed one library. So now you have the complete package, right? So you know that it works and it is tested, and you just have to open it, run it, and it should work, right? So developers, they don't have to go and debug a lot of those things. They are able to focus on the business logic. Currently, enterprises have a mixed situation. Pretty much most of the enterprises today, they are looking at creating all new applications in containerized space. So now you're adopting a new technology of creating applications in a containerized world, but at the same time, you have all these applications that are sitting there for years using a different system. So the app-to-container primarily deals with Java and .NET applications. So why don't we start there, right? What are the roadblocks with respect to modernizing Java and .NET applications? There are some certain hardship, especially associated with containerizing, right? Maybe your team lacks the knowledge about that older application that you want to move to containers, right? Maybe people developed that application has long gone, right? Or your team has no prior knowledge about cloud or containers. And lastly, that might not be your priority because it works, right? Why touch it? So we to help customers in situation developed app to container. Shortly, we call it A2C, and basically. AWS app to container is just a command line tool that helps transform the existing applications running in servers, virtual machines, into containers, right? And it's doing this without needing any code changes. So A2C discovers the applications running on a server, identifies dependencies, and generates relevant artifacts for seamless deployment to Amazon ECS and Amazon EKS. As you may already know, Amazon ECS is Elastic Container Service. It's a container scheduling platform, container clustering platform that we developed. Or you can also deploy your artifacts to EKS, which is Elastic Kubernetes Service. It's a managed Kubernetes cluster solution from AWS. App to Container currently supports ASP.NET, to be more specific, .NET 3.5 and up web applications that are running in IIS 7.5 and up on Windows servers, and A2C packages these applications with Windows containers. Secondly, A2C also supports Java applications running on Linux. It can be standalone JBoss, Apache Tomcat, and generic Java applications. And basically, for example, if this is a Windows application, right, .NET, ASP.NET application, A2C detects if the site is using Windows authentication and generates artifacts for Windows authenticated IS applications. Very simplified and smart approach. So deep dive on the components and some prerequisites. As you may see on the left-hand side, the source, which can be a virtual machine, an on-premises server, physical or virtual. It could be Amazon EC2 instance or any compute instance, any virtual machine running on other cloud platforms, right? Your application is here. It can be an ASP.NET application or a Java application, right? And the component that we developed is A2C, right? App to Container tool. What do you need, right? What are the prerequisites to use this one? First of all, on this side, right? I mean, you can take this as the box, right? Your virtual machine. You need an application. You need the application server, right? But of course, you are not doing this on the production server. Most probably, you're cloning. If this is a virtual machine, you're cloning an application server and using it as a test platform, right? You need a server that is running the source application, right? So then what do you need on that server? You also need AWS CLI. You install AWS CLI. You install Docker tools, Docker engine and tools. Assuming that it's a Windows server, you would need PowerShell 5.0 and up. And additionally, so you would need to provide IAM permissions so that app to container can interact with AWS services, right? So you have this part, you install dependencies, right? The requisites, and you also download and extract the app to container tool, right? And that tool would require permissions to interact with the resources, right? So app to container, when you run it, it generates some artifacts for applications, such as it creates the necessary DLLs for the application, the source code, Docker file, right? It creates the container image in ECR. ECR, as you may know, Elastic Container Service, which is a private container registry, right? It creates container image in ECR for you. It creates ECS task definitions, which means the configuration that you would need to configure ECS. So you don't need to do it manually. It also creates this artifact. Based on the options that you choose, it can also create Kubernetes deployment YAML, right? So it can give you the YAML file for Kubernetes, and you can just use that YAML file. You don't need to manually configure anything. Another artifact is the CloudFormation template, and I think that's the most important part. It creates the CloudFormation template, which is the orchestration tool. CloudFormation is our orchestration tool, infrastructure as a code tool. And with that template, we deploy the resources on behalf of you. Actually, you deploy the resources, right, using this template. It can even interact with AWS lifecycle management tools, such as Code Pipeline, Code Build, and Code Deploy, to also build a CI/CD pipeline for you. You may ask, maybe you have an application with multiple tiers, right? You can use A2C, app to container, to containerize each application tier separately. A2C creates separate containers and corresponding AWS deployment artifacts for each individual tier, right? So next, a demo about app to container. So first, I go to my Windows server. So in this screen, so let me also check if, yeah, you can see my screen. So here, as you see, this is my Windows server. I have my application. So pardon me, I'm coming from an infrastructure background, so it might look funny for some of you. So this is just a basic sample web app file, right? Web application components that I have here. And I deployed it too. It just has this index.html and date ASPX file, just shows the date, right? And I deployed it to my IIS server here named web app. And that is the application files that I'm storing with this application server. So if I go to the localhost to check it, it's just hello world, click to see the date. Yeah, I click it and it shows me the date, right? That's so simple. So this is an application, web application, running on my IIS server. I am planning to move this to AWS using app to container. I want to containerize it. So how it works, so steps are clear, right? If I completed all the prerequisites such as AWS CLI, necessary IAM permissions, also PowerShell, right? Latest version of everything is ready. And I downloaded app to container, right? The first thing that I need to do is, these are all documented, right? You don't need to follow it from here. We have very nice documentation about it. But what I will do is initially, first, what you have to do is first run apt to container init command. So go to here. I did it already. What it does is it just creates the necessary folder that it will access. It assumes the role, the IAM role that it will use to do every other shenanigan. So the next step is to create the inventory of the applications that are running on this server, right? So I come here, and what I will do is I will just run the inventory command. So as you see on the server, I have the default website, which is stopped, and it's already listening port 81. So everything that I depend on, everything that I want to move is this application, right? This web application, which is identified as IIS web app with this random string following that one. So next step, what I will do is, after the inventory collection, what I'll do is I will just analyze this application. So the tool will analyze the dependencies, all the required components, and what I need to provide is the ID of this application. So when I hit it, it is analyzing, right, all the components, either framework-related components or operating system components that are associated with this server, to build the artifacts that it might need to create the container, right? So this is the initial step. So this is the folder, right? So let me refresh this folder that the application is analyzing. So after analysis, right, this is the folder that is using. Let's see, it is completed, right? It created this analysis JSON file. Let's double click and see. No, what is this file? This is also documented. This is just the metadata after the analysis. It shows us what it detected on the system. There are some configurable options here, like, okay, this is the operating system detected, the name of the application, the IP, the IIS version, the local port that is bound to, and also the features installed on the server. Because the assumption here is, oh, this server, if I installed these features, it should depend, the application might be depend on these features, right? Obviously, this is my test server, so I installed many features, removed any features, so obviously I won't be needing this, right? So if there are any features or stuff that, or any binaries you don't need, you are free to remove them before containerizing it. This is the analysis. And obviously, I mean, these are the stuff that I was using for some tests, so I won't be needing these, right? So I just removed them. And I saved the analysis JSON, because the subsequent steps, which would be the containerize step, right, would use this analysis JSON file to create the to create the next set of artifacts. So I'm going back here. The nice thing about tool is, after you analyze an application, it's giving you the next possible command, which is use apt to container, containerize, an application ID is already here, right? This is the output of the command. So it's assuming that I analyze the application and I will containerize that application. Very good. So let's do it, right? I will containerize this application. So this is the folder, right? Currently, I don't have any more data than the analysis and the report and maybe some editable files folder. But look, after I do the containerize, which artifacts will be created? So I just started the containerization step. So it's doing the containerization of this application. So when I come here, if I refresh, I see that, oh, now I have more, right? Now I have a deployment JSON, right? And if I go back to my command line, I see that the next comment is, it says, okay, now since you generated those, the next command is to generate the deployment, right? And I will run that one, right? Apt to container, generate app deployment, and this is the application ID. I will run that one, right, to generate all the resources. So this step basically generated the CloudFormation template, right? As you may see from here, I containerize, and last step is apt container generate. It creates the deployment artifacts. And basically what this is, it creates a CloudFormation template, a YAML file, which is on this directory, right? It gives a name for the stack. You can see the stack name here. This is an AWS CLI command. That is where it needs AWS CLI, right, to do this, right? So the next possible step, it recommends that you can also generate the CI/CD pipeline for this application. That's the next recommendation. I won't do that, right? What I will do is I can run this to initiate the deployment of this CloudFormation stack. But I did it already for you because since this is a Windows container, they are large, so it might take 15 to 20 minutes to complete the deployment. And it's not just the Docker image download and also deployment. It creates all set of resources around this. So I will show you that now. So if I go back to my AWS console, here, I'll go to CloudFormation. This is the one that I did today, which is, don't show me the nested. This is the CloudFormation stack that is generated and I deployed. So if you check the resources that are created by it, you will see it deploys other CloudFormation stacks. So as you may know, with CloudFormation, you can use nested stacks. So you have a parent stack, right? And the parent stack deploys the child stacks. So they all have, if you see the details, right, the nested stacks, each stack deploys a different portion, different part of this architecture. So one of them creates the network. One of them, for example, this one creates the subnets and the networks that it will deploy the application. Another one deploys the load balancer and creates listener, right? We are also placing a load balancer in front of it. And then another one creates the ECS cluster, and then everything is deployed and the application discovery service is triggered, etc. So let's go back and check the ECS side, Elastic Container Service side, because I ran that CloudFormation template and the application is migrated to using the same settings, right? I just did it before this session. So as you may see, the first thing that we should point on is, first of all, the image is imported to the ECR, like the container registry. This is it, right? So I can use this image to deploy my containers, and it is also a part of my CI/CD pipeline. So whenever I update or trigger the pipeline, this is the final, right? I will have the latest version of the image here, and that will be deployed. If I go to the clusters, this is the cluster deployed by ECS, right? And it is running a service, which is the image of the application that I converted using A2C. So let's try to access it. So the tool created a load balancer for me and positioned the load balancer in front of this application. I'm going to EC2 console where I can see my load balancers. And after, some turns, I see that this is the load balancer created by this stack. Everything is automated, right? I just run that stack. Everything is created for me in 15 minutes. So I copied the DNS name of that load balancer. You remember the application, my very simple application. It works. So it shows me the date. So the application is here. It's very simple. It simplifies the containerization and the deployment, and it can even build the pipeline for you. I really like the tool, and I highly suggest you to give it a try. So this was the first service that I'd like to mention. So the second part. So A friend of mine shared this with me, right? And do you think this approach works, right? In case of a cyber attack, if you pull all the cables, yeah, I mean, it definitely works, right? But the timing wise, you might be late and or it's very error prone, right? If you do things manually, it's very risky, right? You might have lots of false positives or false negatives. Either case, it's bad. So every architecture has complexities, multiple implementation steps, and my personal favorite is high availability features and solutions for SQL Server and MySQL Server deployments. There are lots of moving parts, right? And things to plan, execute, and test. And basically, customers asked us, how can AWS make this experience better for them, right? And we built AWS Launch Wizard for SQL Server. So basically, let's take a couple of steps back. Why? So why we built this? The complexity of these environments, like these kind of deployments, can delay some projects and testing, etc., because it requires domain expertise to set things up correctly. It's time consuming to install, configure, and test to set everything up correctly. And due to the complexity, any configuration errors can take extensive troubleshooting process to resolve, right? So that's why we built AWS Launch Wizard. And Launch Wizard for SQL Server, it reduces time it takes to deploy SQL Server high availability solutions in AWS. And this is a guided experience, right? With Launch Wizard, customers can deploy SQL Server always on availability groups on AWS faster and more easily. This is a guided step-by-step process. It lets you to deploy and configure AWS resources for SQL Server always on in a kind of wizard-like approach, and automates the deployment of AWS resources on your behalf. So here's how it works. I will do a quick demo about it. So this is our amazing application. I can push the artifacts to GitHub if you're interested in. So Launch Wizard. So as you may see, Launch Wizard has two deployment options. You can also deploy SAP, but today I will be doing SQL Server. You choose an application. I'll deploy SQL Server. You hit create deployment. Basically, it just requires an IAM role, right? Permissions to perform those actions on behalf of you. Next. It asked which operating system you want. And as you may know, SQL also runs on Linux since 2016. So you can also test it here. But I will stick with Windows for now. You can also choose single instance deployment or high availability. I mean, the complexity comes with high availability deployment. So I will stick with high availability again. So it asks some information about the deployment name. So I will say this is SQL 1. The deployment name is SQL 1. It's a very innovative name. You can give an SNS topic to get notifications like it started, it's finished, etc., because it will have multiple steps, as you may see on app to container, right? It also had multiple steps, right? Because it's interacting with multiple resources. And here, okay, I also choose a topic to get notified. For connectivity, it asks, okay, which key pair I use? As you may know, key pairs are used to generate passwords and specific and private to customers. Tenancy model, you can either run your SQL servers in shared tenancy or dedicated host. Dedicated host is for bring your own license scenarios. If you're also planning to bring your SQL licenses, Windows licenses, that are possible based on when you purchased your license. I will stick with shared tenancy again. It's just about the tenancy, right? It's not about SQL's deployment. Then you choose which network you will deploy, right? So I say, okay, I will select a VPC that already exists. First of all, it asks me a public subnet. Okay, I'll just use this public subnet on AZ1. then of course you will not be deploying your SQL servers in public subnet. So it's asking you to give some private subnet. So I say, okay, in AZA, I use this subnet. In AZ2, since this is highly available, it asks me multiple availability zones, right? And also, you see, it also creates a remote desktop gateway for you, and it says, and you see my IP address here, so you can start a DDoS attack towards me. Also, next, since this is an always-on availability cluster, it requires Active Directory, right? And you can either use your existing Active Directory or you can use AWS Managed Active Directory. I have one, so I will use that, but you can use your existing Active Directory with that. So I will apply the password of my managed AD. Very complex password. And its DNS name is amad2.local. AWS managed AD2 local. Obviously, I installed another one, so this is named amad2.local. Next one, it asked me for SQL Server service account, right? Because to run SQL Server service need an account, right? And I say SQL, let's say just account 1. And it asked me for a password. Hopefully, oh, they don't match. Bravo. Yeah, I made it. Cool. So next, it asked me if I want to use a custom AMI, an image, a machine image that I created, or a license included AWS maintained and managed instance. I will choose, okay, I will use an license included AWS AMI. And here are the options, right? You can choose Enterprise Edition 2017, 2016. So let's go with the latest and greatest, which is 2019 Enterprise Edition, okay? And here you can see some additional settings, right? Okay, name of the node. So I want, let's be creative, node 1, and the second node is node 2. You can even add additional secondary nodes. Let's say maybe you will have a node 3, right? And maybe this would be your read-only node in this subnet, etc., that you can even add more, right? Up to 5 additional nodes you can add. And the database name, very creative as you may guess, database 1, availability group name AG1, listener name, listener 1, and cluster name, of course, cluster 1. So I hit next. I missed something, missing fields. Let's see which field are missing. Oh yeah, I need to confirm, right? Okay, so next step, it asked me, how do you want to scale? I mean, what kind of instances, servers do you want? You may say, I will size this based on the infrastructure, right? Based on the requirements from my vendor, from my consultant, etc. And this is maybe, you would say, okay, I would use 4 cores, this amount of memory, or you can choose it based on AWS instance type. And you might be familiar with those, right? I can choose C5, R5, X1D, X1, Z1D, etc., X1, those kind of instances, and also EBS volume types. So I will do it based on the infrastructure, right? Let's say currently I'm using 8 cores, and I want 8 cores on AWS side. Maybe I need this amount of memory, right? This amount of throughput and the disks, etc. You can also choose the type of disk and the throughput that you want, etc. So you can also see the recommendation here, right? It recommends you use R5A 2x large with GP2 volumes, but you can even further customize it. Come here and say, look, for here, I want a volume size of maybe 200, and you can even do like, wait, I even maybe need more, right? More throughput. Let's use some IO1. So this is too much for boot volume. I don't need it. You can say 500 is okay. For log volume, maybe I need more. For data volume, maybe I need more IOPS, right? 10,000, and the data size is maybe 2 terabytes. And backup, of course, it would be at least 2 terabytes. You can add tags, and the great thing is you can see how much you pay per month, right? Including the infrastructure, including the licensing, plus the directory, right? You are provisioning a managed AD with that one, or using an existing one, whatever you may prefer. I decided to use another new one here. So based on my input, this is what it costs. So if I hit next in the screen, this is the summary screen. When I hit deploy, it starts the deployment. But actually what it does is it creates CloudFormation stack, CloudFormation template for me that it uses the artifact for that stack. So if you need to deploy another one, you can either run the wizard. We are not charging you for running the wizard, so you can use it as many times as you want. But the output of this process is a CloudFormation template, so you can use that CloudFormation template for your further deployments. So I'm hitting cancel here, and I'm approving. Okay. Okay, so next one. I'll speed up a little bit. So next one is AWS Dev Fabric for SQL Server. First things first, this is for development use cases, right? Let's agree on that first. What I will talk about now is just to save money while you're developing an application, which may use SQL Server, right? Maybe you have a SQL Server application that you want to deploy, and you want to cut some cost, right, while developing it. Because more often than not, I see customers using Windows servers, paying for the Windows Server license, running additional servers and managing and maintaining those servers, and also using their SQL licenses that they paid for in development environments. At best, they install Developer Edition, but they still pay for or use Windows Server licenses, Windows servers, and the operations of these systems, right? What if I have something that I don't need to manage any servers, don't need to pay any server or SQL Server license, and have it when I need it, right? Let's talk about AWS Dev Fabric for SQL Server. So this is not an AWS service actually, but it's a solution developed by Special Solutions Architect to address a pain point. So first discuss what was this pain, right? What are these pain points? Let me have all of them on screen, right? As part of my job, I'm part of many optimization and licensing engagements with customers. Paul also mentioned this. It's a program where we run some tools to assess customers' utilization and licensing situation to help them before they move to AWS. So this helps them to right size and optimize before they make that move to the cloud. And what I have seen in many real life cases is that customers are using standard or worst enterprise licenses on development environments, right? Sometimes they are using MSDN subscription, but Microsoft removed bring your own license from MSDN subscriptions as of last year. Also, it requires you to patch and update an additional system, right? You can't let a system unpatched, unchecked, uncharted, right? It has to be maintained also. And another one is since you may know, we have Amazon RDS, right, which is a very popular managed database service, right? Amazon RDS for SQL Server, it doesn't support Developer Edition, right? Because of licensing stipulations. You can't run Developer Edition there. So if you don't want to manage any servers, anything, but just want to use SQL Server, then you have to pay for the license there, right? So that's not good for cost optimization, right? So Dev Fabric for SQL Server is 100% serverless solution built with AWS services. So at the heart of the solution, we have AWS ECS again, Elastic Container Service. I'm trying hard selling that service today. So SQL can run on containers, right? We know it. So, but the solution is not just ECS, right? That's an ecosystem. This is an ecosystem of other AWS services around Dev Fabric. So ECS Fargate is completely serverless solution to run containers, right? We use it for the solution. Then to capture the containers, right, running in Fargate, AWS Fargate, we are using CloudWatch, right, our ubiquitous monitoring and logging tool. The solution also wants to make sure that you can access the containers through DNS name, right? So we create a private zone in Route 53 and Cloud Map for service discovery. We need a mechanism to persist data on EFS, right? And that is Amazon EFS, Elastic File System, which is a managed NFS server, right? As part of the ecosystem, we also use AWS Backup to back up the databases, right? Also Lambda to support custom resources and also generate random passwords while creating the solution. Secrets Manager to store and support a secure way to store passwords, right? And of course, CloudFormation is the underlying service to orchestrate everything here. So that is an ecosystem for running SQL Server in a serverless environment, right? Let's go a little bit deeper. So how our solutions architect built this? We mentioned Fargate, right, which is a serverless container solution. The solution basically consists of two parts: the control plane, and the data plane. After you clone the necessary artifacts from GitHub, I will share the link end of this presentation, at least this end of this section. And after you deploy the CloudFormation stack, it first creates an ECS Fargate deployment, right? Then it creates the Route 53 private zone and uses Cloud Map for service discovery. It creates an Elastic File System, EFS, as the data store, right? Lambda to fill the gaps where necessary. And next, it also deploys the AWS Backup to back up the files on EFS file system. All right, so continuing on the components, the data plane, the second part that you deploy. So you also download the CloudFormation template for this. So when you deploy, data plane is another CloudFormation stack. Data plane is also running on Fargate. We use SQL Server Ubuntu images, right? So we download first CloudFormation download SQL image from Docker Hub, which is maintained by Microsoft, either 2017 or 2019. Then Lambda functions used to create the random SA password and restore and store it in Secrets Manager. The solution creates EFS, creates two paths in EFS and injects them into containers for persistent data store. One of them is /var/opt/msql. This is where the database binaries and database files will reside. And /backup is for backups and restores. And again, the solution uses Route 53 and Cloud Map service discovery features and registers the A record for the containers to Route 53. And finally, the container logs are streamed to CloudWatch, right? So this the control plane and the data plane. So as you may know, containers, they are ephemeral, right? So you have a container, right? Maybe running in availability zone C, right? So we downloaded and deployed Ubuntu-based SQL Server, which is storing the data on EFS, right? What if the container dies? It's possible, right? Containers are ephemeral and they don't store data. Is my SQL data gone? No, since if this is gone, if the container dies, Fargate automatically triggers another container, creates another container. And since the data is on EFS, the solution automatically remounts to EFS. Again, you will have this data path and the backup path attached, injected to the container. And also your new name is again registered to service discovery, and you will assign a new FQDN with this one. This is the GitHub link, but you can just search AWS Dev Fabric for SQL Server. Just Google it and it will show you the link. Again, this is SQL Server Developer Edition running in Ubuntu Linux container. It is serverless, so there is no SQL Server license cost or Windows Server operating system license cost. It is also serverless, so you are not managing or maintaining any servers, right? It's very nice if you just want to test some applications, and those applications need a SQL Server backend, right? All right, and the final chapter is about Amazon CloudWatch. So there are two nice features, sub-features that I really want to talk about. CloudWatch, one of them is Application Insights for .NET and SQL Server, and the other one is Log Insights. So without further ado, I just want to give a background, right? So IT operations, right? We are doing IT operations and maintenance and monitoring, whatever it may be, right? It includes overseeing and managing the daily and routine tasks, such as maybe software deployments, creating backups, maybe patching servers, maintaining the desired states. And you're also doing monitoring, which is gathering metrics and logs, ensure everything is functioning as expected. In a typical data center environment, these functions, such as monitoring and maintenance, are carried out by servers and software, right, which themselves require maintenance and monitoring, right? So as you see, this might be a typical data center where you have your corporate data centers and maybe some disaster sites. You have your application servers, you have your database servers, some dev test systems, domain control, lots of components, right? But you also have monitoring systems, you have configuration management systems, some infrastructure servers that also requires maintenance, right? So with some managed services that we will talk throughout these sessions, today I will just cover the monitoring. You can get rid of these servers, right? And the monitoring of these additional servers, maintenance of these additional servers. That's the point. So Amazon CloudWatch is the core of our observability solution, right? It collects monitoring and operational data in the form of logs, metrics, events, and you can also visualize these using dashboards, so you can get a unified view of your AWS resources, or also on-premises systems, because you can also push logs and metrics to CloudWatch. You can correlate your metrics and logs to better understand the health and performance of your resources. You can also create alarms based on metric thresholds. With a single click, you can enable and watch for anomalies in metric behavior based on some machine learning algorithms. So it analyzes your patterns, and if it detects some anomaly based on your previous usage patterns, it can give you alerts based on the anomalies that you are experiencing. You can set up automated actions to notify you if an alarm is triggered and automatically start any action, right? Maybe auto-scaling, maybe repairing some resources to reduce the mean time to resolution. And finally, you can also dive deep and analyze your metrics, logs, traces to better understand how to improve your application performance. A nice feature regarding Windows applications is AWS CloudWatch Application Insights for .NET and SQL Server. When you add your applications to Application Insights, right, it scans the resources in the application and recommends and configures metrics and logs on CloudWatch for your application components, right? To onboard your .NET and SQL Server applications to CloudWatch Insights, you must create a resource group that includes all the resources, all associated AWS resources. used by your application stack. This includes the application load balancers, AWS EC2 instances, running IaaS front end, maybe a .NET Worker tiers, and your SQL Server databases. Application insights, after you group your resources in resource group and enable application insight, it analyzes metric patterns using your historical data to detect the anomalies. It continuously detects errors and exceptions from your application, operating system, and infrastructure logs. And it can also correlate all of these to give you a better insight, right? It can create dashboards that show you relevant observations, problem severity information, that you can maybe prioritize your actions, right? So, next one. So configuration of application insights is also very straightforward. After you reorganize your resources under resource groups, you add these as applications under CloudWatch Insights. And based on the components you choose, such as IaaS frontend, SQL Server database, different performance metrics or logs or events are added by default. But of course, you can customize this, right? Because in an IaaS web server, some performance metrics might not be important, right? Or maybe in a SQL Server, there are some important metrics that you really want to see. Those are included because application insight is designed based on some best practices around running those applications. So again, I will show a quick demo about application insights for .NET and SQL Server. I also mentioned log insights. I don't have any slide about that, but I will include it on my demo. So let's go back to our AWS console. The first thing that I will do is going to CloudWatch. So after I go to CloudWatch, so this is the landing page, right? When you first reach it, since I enabled the application insights, it added these dashboards here, like this application. This is monitoring my CPU stats, some other metrics, and these are added automatically here. If I have any problems, they would be here in the problems detected section. So it's last 3 hours. So let's increase it like last 6 days. Last 6 days, I had a lot of medium severity, high CPU problems. There are some well-known best practices around running some .NET servers or SQL servers. So if that is more than that defined threshold, which is also configurable, it triggers these problems, right? So how do I enable it? Basically, you just go to settings and you enable it in the application insights section. When you go to view, I already added a resource group right here. You can add additional applications by clicking add an application. And if you have a resource group associated with that application, you can immediately add it. I've done it already for you, this resource group. Actually, it just contains one component, which I named my custom component. You can get some overall information here, but if I click this component, and it can have multiple components, I see that this resource is an EC2 instance with this ID, and it's a domain member, and that's just the name tag. So it's bringing the name tag. It has many volumes attached to it. The operating system is Windows. So let's click Manage Monitoring to see what can I change, right? First of all, when you add a component, you choose the tier for the component. And for this one, I chose SQL Server because it's running SQL Server. But there are also other options that you can choose here. You can say, oh, this is an IaaS server. This is, I don't know, a Java application. When you choose that tier, it automatically brings the associated logs, which are very important for that workload, events which might be important for that tier, also some performance metrics that you can that you might need, right, or that might be important for you. And you can even add more, right? You might see some standard CloudWatch metrics here, which are available by default. or you can see some specific metrics which are not available by default if you don't enable this service, right? Such as normally you won't get these metrics from within the instance, right? Like memory utilization, like, I don't know, a SQL Server logs, etc., right? Because by default, because of the shared responsibility model that we have at AWS, we can just monitor that we can see out of the hypervisor, right? Like your CPU utilization, the network in, out, read, throughput, etc. We can see your memory utilization. And obviously, we can see your SQL stats, right? We can see your SQL metrics. You have to push them out. CloudWatch already supports it, but you have to configure the CloudWatch agent or Systems Manager agent to push them out. But if you enable this service, they are done on your behalf, right? So these are the stuff that are monitored. So let's go and check, right? I configured it already. Let's go and check these metrics that I'm pushing to CloudWatch. In the metrics section on the left-hand side, I chose metrics. There is a namespace which is called CloudWatch Agent. And if I choose metrics based on instance ID, oh, you see there are some metrics that I'm pushing out of these instance, such as maybe this is very important for me to monitor the SQL Server buffer cache hit ratio, which is a very, very important metric if I want to make sure that I have enough memory on this server. Or this is also coming from the from within the system, which is the CPU utilization or available memory. These are all coming from the application insights. Application Insight is sending these metrics out from the systems that I'm managing using Application Insights. Other than that, it's also emitting the events. I'm also close to the end, and I can see them on the logs, right? The Windows event logs are sent to log groups, and the log group that I configured there for this one is this log group, right? And there is this log stream in that log group. And as you may see here, oh, these are the logs that I'm collecting from that system. That server also has IAS running, right? The system that I showed the demo about app2container. So I'm pushing IAS logs here to CloudWatch. And here you can do some basic searches. Maybe you can say, okay, I want to see IAS logs which have AD, right? I'm only interested in the entries that have AD, right? Port AD is important for me. And you can do some basic filtering here, such as, okay, I'm interested in AD, but successful HTTP requests, they are not meaningful for me. I'm more interested in if things are not successful, right? Maybe someone is probing my web server. So I said AD minus 200, which means I want everything that has AD on that log entry, but I don't want anything that has 200. So here, oh, I see that there is 404. Someone is trying to access some paths that I don't have on this server, which might indicate something bad, right? So that is already proven nice and useful for me, but the functionality on this filtering is limited, right? So I have lots of logs, but if I want to do more logic, it won't work for me. For example, look at this. Someone is trying to reach to login PHP, which is non-existent in this sim, because this is an IIS server, right? I'm running just a simple ASP.NET website, and this doesn't exist here. So what if I need more insights on the log? So as the name implies, I can use log insights. So when you come to log insights, I will first choose the window, right? Let's say 6 days. I choose which log I want to analyze. Again, I'm interested in my IIS logs. Maybe I have lots of application servers, so I will just analyze this. There is this default query that you can see here. And if you click fields here, you can see that in this log, the detected fields are log field, log stream field, message, timestamp. Okay. These are very well documented, so I highly suggest reading the documentation if you're interested in the query language here, but it's pretty easy. So first, this is the default query that you enter. You can see it here. I also have some saved queries. But it says fields. I'm interested in the fields which are categorized as timestamp and message. I want to sort everything based on timestamp descending and just bring me 20, right? That's very simple. So if I run this query, oh, nice. It even visualized it for me, right? In this timeline, it also draw a histogram for me. And these are the log entries, just 20 of them. And if you see, yeah, this is the timestamp, right? And this is the message. The important part is the message, right? So let's try to get more insight from this message, right? Using the functionality provided by Log Insights. I go to the saved queries. I saved the query here, which is, I named it distinct visitors. Let me show you what that means, right? So what it does is, first, I want these fields, right? Which are, I want timestamp field and also the message field. The second one, I use the function, built-in function, very well documented again, which says filter, right? And I want to filter what? The message. And then after like, you can give a regular expression, right? I'm not that smart, so I Googled this regular expression, and it's the regular expression for IP address. So what I said here is, bring me the timestamp and message and filter everything for the lines that contain IP addresses. So if it contains a valid IP address, I want it. If it doesn't, just skip it, right? It won't bring it. So let's test it up until here, right? To prove the point. So I commented out the rest and I run the query. So what it gives me is the lines that only contains IP addresses. So everything except IP addresses filtered out. Oh, next one. What I said is there is another built-in function which is named parse. And what I do here is parse the message. This is the pattern. So I analyzed the message, right? And it's pretty obvious that it has values, space, values, space, values, space, and it has 10 values separated by spaces if it contains IP. So this is that pattern, right? I said parse this based on this pattern. So it categorized it based on empty spaces. And then what you did is assign every part parsed, starting with, this is just a name I use, so you can make it X1, X2, X3. I just used P1, P2. So since I have 10 fields, I named them P1 till P10, right? So if I run this query, it, as you see, allocated each and every different section, which are separated by spaces. And as you see, the P9 contains the IP address, right? So what if I only display that one, right? I only want to see the IP addresses coming to my IIS server, right? Oh, these are the IP addresses, and I have over 1,300 IP addresses coming to my IIS server. Very nice. So maybe it's Black Friday, things are going good. And the last bit, right, that I add, another function. I want to use stats function and just count distinct values, like a distinct function in SQL, right? All the distinct values of 9 and name it from IP addresses, and also count all the P9s and write it as number of records. So if you run this, let me show you the result. So basically what it brings me is this server, based on these IIS logs, are accessed by 181 different IP addresses these times, right? So it's obvious that some IPs are coming to me multiple times, right? This can be something that you can also embed to your monitoring tools and systems. And here what I'll do is I will add this query, right, as a dashboard. And let's see, oh, there is a dashboard which is already created for me by Application Insights, and I'll use it. And I will add this as a logs table, right? And add to dashboard. So as you see, so in this dashboard, I have this, right? And what else I can use here? So now we jump to another topic, which is dashboards. I can I can add widgets. And this is the last bit, like line widget. Next, I want some metrics to show here, and like CloudWatch agent, I want to see available memory. Maybe there is a correlation between the number of hits that I have and the memory, right? So you can get great insights, right? You can combine all the logs and metrics, turn them into nice dashboards, and these dashboards, you can put them on your operation, in front of your operations team, and they would have amazing information from both from the cloud platform, from the operating system, from the logs. That's great, right? And I save it. And with that, I would like to thank you for listening to me. Let me go back to my presentation deck. Yeah, thank you. So we don't have a Q&A session, but Walter, I think if we have any questions, you can read them out loud to me. Otherwise, this is my email address. You can reach out to me, or we have a big alias, migrations@amazon.com. You can reach out from there to ask your questions.
Yes.
All
thank
right.
you so much, Baris.
Thank you. Thank you for having me, Walter.
Quite interesting.
Like
a little bit longer, maybe after a full day of work. But
I always use my time to the fullest, right? We agreed on 8.
I'm totally fine. I'm happy to see these things, because these are the indeed, as the title of your session says it. I didn't know that AWS can do these things.
I have plenty. So this is just one Walter. So if you're okay to get more tired after work, we can have some follow-up sessions.
We can do a next one. We have we will go back to having a meetup every month. So I'm happy to have you again in the next meetup or meetup after that. Definitely be interesting.
Thank you.
Yes, I'll keep it short. Thank you very much for your presentation, and the how to say that, the recordings will be on YouTube right after this, after we close the session, actually, because that's the advantage of this whole YouTube Live setup. If people have questions, they can come to you or ask them in the meetup group. You cannot currently ask them in the meetup group because meetup is down for the past 2 hours. And I see there's a relatively large AWS outage going on as well. Sorry to curse in church, but it's a little bit difficult for people to ask questions right now. But I'll be happy to forward any questions that come in on the meetup page to you and Paul as well.
Great, thank you.
All right, thank you very much for your time, and
thanks for having
everyone
me.
who's watching.
Thanks for listening. Thanks for enduring till the end.
I learned a bunch of new things, so my evening was well spent.
Cool, thank you. Nice to hear that.
Yes. All right, Baruch. Have a nice evening.
Okay. You as well.
Watching this stream,
cheers, everyone.
Goodbye and have a good evening. Bye.